Hello. Okay, so we are going to start our discussion of Chapter 5, looking at forces in two dimensions. So we've already talked about force in one dimension, either horizontal or vertical, but in the real world, things move in both dimensions, and so now we're going to talk about how to put those together. So what we're going to start with today are vectors, which are the arrows that we draw on the free body diagram to show the different forces. And so we're going to talk about how to add those together when they're in different directions. Okay, so we've got forces that are not just horizontal or vertical. So like we said, we have to figure out a way to put these together. So vectors can be added even if they do not point along the same straight line. So we know that vectors that are along the same straight line, either horizontal or vertically, we can just add them together based on their direction. Okay, now we're going to talk about how to put things together when they're horizontal and vertical. We add vectors by placing them tip to tail and then draw the resultant vector. So for example, if I have a vector moving this direction and I have another vector, let's say that is vertical, I can take this vector, move it as long as I don't change its direction or its amount or its magnitude, and I can line it up tip to tail, so I'll line it up right there, and then my resultant is the one in the dashed line, which goes from the tip of one of my vectors, or the tail on one of my vectors here, to the tip on my other vector, and that's the resultant vector. I could do this also with only horizontal or only vertical. So for example, if I had a horizontal vector and then I had a second horizontal vector, if I put them together, this would be my overall resultant. Let's say that I have horizontal vectors, but they're going in opposite directions. So I have this one going to the right, and I have a second vector going to the left. Well, my resultant vector is going to be the addition of those, but because one is in the other direction, it's really a subtraction. Okay, so let's talk about how to find the resultant vector at an angle. So traditionally, we could use Pythagorean's theorem, and there are two main ways to find the resultant vector. So Pythagorean's theorem is the most common. So r squared, or a lot of times you'll see it as c squared. We use r because r means resultant, is equal to a squared plus b squared. So if you take a look over here, a is one of the legs of our triangle, and b is the other leg of our triangle, and c or r is our resultant. This will only work if the vectors are at 90 degrees from each other, and so that's what this indicates, that a and b are at 90 degrees. Okay, so you can only use this method if that's your situation. The two other ways to add vectors are if the two pieces of the resultant are not at 90 degrees. So the first is law of cosines, and this is r squared equals a squared plus b squared minus 2 times a times b times the cosine of theta, or the angle. Okay, and so this would be an example of a triangle that is not at 90 degrees. Okay, and so looking at either angle A, angle B, let's see, or angle B. And we'll do some examples with this in class. The other way that you could add these together is to use the law of sines. And so for law of sines, you don't need all that information. It's r over sine of theta equals a over sine of A, which equals b over sine of B. And so you only would need 3 of these pieces of information to solve for the fourth one, instead of all the different sides or angles. Okay, and again, we'll do an example of this in class. Okay, so let's talk about how to do what's called vector resolution, which is basically the process of breaking up a vector into its components so that we can add 2 different vectors together. So we can take a vector and break it down into its components, or the x and y parts. Okay, and there's lots of different types of vectors out there. So let's look at one that is only horizontal. So if this is vector b, we would say that if we broke it into its components, or its x and y parts, that b sub y would equal 0, because this vector is only pointing in the horizontal direction, so it has no y component at all. This would also mean that b sub x, only the horizontal part, is equal to just the vector b. Okay, well, what if we had something like what's pictured here, where r, our vector, is at an angle and does have an x and a y component? Okay, so then we would break this purple vector up into its y component, shown here in green, and its x component, shown here in red. And we're going to talk about how to find the values of all of these vectors. Okay, so we can find the components of any vector by using trig. Okay, and there are 3 trig functions that we're going to need to know how to use. cosine, sine, and tangent. And so a lot of you may have learned in math the SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so SOHCAHTOA. Okay, so however you can remember that, but if you need to put these on your note card, that's fine too. Okay, so cosine of the angle is equal to adjacent over hypotenuse, and let's draw a vector in here. So that would mean that our adjacent, if this is our angle, our adjacent is our x component, and our opposite in this case is our y component, this being our resultant. Okay, and so we could use cosine of the angle to find x. We could use sine of the angle to find y, since it's opposite of our angle. And then we can put these together and use tangent as well. Okay, so to add two vectors, we need to take each vector and resolve it into its components first. So if you take a look at this picture, we have vector A and vector B, and we have taken vector B and resolved it into its x and y components, and we've taken vector A and done the same thing. Okay, and if we go back to our picture of the coordinate system, keep in mind that anytime you are over in this coordinate that your x component is negative and your y component is positive, and then similar ideas follow for all of the rest of your coordinates, this one being positive and positive. So keep that in mind when you are resolving your vectors. Okay, so once we've resolved both of vector A and B into our x and y components, then we're going to add all the x components together. So in this case, r of x would equal a of x, which based on this picture is going to be negative because it's pointing to the left, plus our b of x. Okay, then we're going to add all of our y components together to get r of y. So in this case, this would be a of y plus b of y, and based on this situation, both of these are going to be positive. Once we've got r of x and r of y, then we can use Pythagorean's theorem to solve for our resultant, because now we're going to have a right triangle, our x component, our y component, and our resultant, and to find the resultant we need to use Pythagorean's theorem. We also sometimes are asked to find the angle of the resultant vector, and this is where tangent comes in. We know that tangent is opposite over adjacent, so tangent of an angle. If we want to find this angle, we need to basically take the tangent part and divide it over to the other side. Well, anytime you divide something, it is also like taking it to the -1 power. So theta is also equal to tangent -1 of the quantity opposite over adjacent. And again, we'll do several examples of this in class.